How are you? I'm good. How are you?
He said something. They quoted him on something.
I should be.
And then it's like something about philosophy. It's just kind of like a regular stuff.
Is he mic'd up?
So then we need the assistant.
Yeah, the second person on that one.
Whenever he comes in.
Yeah.
I guess we could change it with the break.
Whatever you think. Should be. If it's not, we can hold. I'm sorry. I don't want to run over your foot.
You don't have to worry about not doing it the same way you did.
Yeah, that mic's live.
Okay. As soon as I see it.
While we're waiting, I just wanted to let the participants know, first of all, I'm really glad you're all here. Secondly, when you're speaking, if you could stay from here to here.
They could come to this end of that.
Oh, this?
Yeah.
Okay.
Yeah.
So if you want to stand behind the podium, you may
Yeah.
then. So from here all the way to the screen, that way they can capture you on camera. Is that correct?
Your mic is breaking.
Can we come check your pack? Good talk.
Okay. Yes.
We have to switch back.
Just to this side of the screen. So
Okay.
remember what we said about if you look, you know, if you you're running a little short, it'd be better before you get to zero.
So we'll have to back up.
Good to know in advance.
Sure is. And then we'll set this one down. There you go. Okay. There you go.
Your recorder,
There we go.
make sure they're even. Maybe turn them down a stove too.
And our first speaker, okay, and that is your slide. All right, good. We're in business.
Here's the kind of on-deck area to get your mic up.
Oh, yes.
Right here.
Yes, and so after the first speaker begins, the second speaker should go stand right
Next to Barb.
next to Barb in black there, and she will hook you up with a mic. And like, you know, we'll just keep rotating that way. So when you're on deck, so to speak, when you're the next person, you can relocate to get set up with Barb.
You can put this part in your pocket, and I'll just add the mic to yourself.
Pocket or belt works, whatever you're comfortable with.
If you want to take the wires, you can get right into the kind of wire cord right up there. You can grab it to the water. Yes.
Okay.
Talking to that mic.
Test, 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 test. Welcome to Iowa.
sit here?
I think I may sit there.
Because I'm like, doesn't look like everyone's.
Yeah, yeah.
We need more people here next time. We need to get a bigger room and more people. Next time we have a bigger room or more people, we should do a raffle. That anybody who comes in can get a ticket like we used to or something. That would probably be a way of joining. At least that's my quick thought.
Okay.
You want something to take them during the thing also?
I guess that would be fine, sure. Yeah, although you won't be standing out there then?
No,
Okay.
we're just going to sit right
Sit,
here and
okay.
make faces.
Okay.
In the opening remarks, can you remind everyone to silence their phones?
Oh, thank
Yeah.
you, yes.
Mark just said that, yeah.
Come on in.
Glad you reminded me.
Yeah. I don't take credit.
Okay. Okay.
But that'd be for the
Audience members.
audience too. so,
Yes.
yeah. Those distractions. Little,
It is.
yeah.
Yeah, if I were one of the contestants, I'd be sweating.
I know, and they have more clothes on than they
Yeah.
might usually wear too.
Yeah, yeah. Oh, hello.
So as soon as we start, we don't let anybody in.
I think as soon as the first student starts to present,
Yeah.
I think if I'm still talking, that's fine. I,
Just in the nick of time.
I start when I start speaking.
yes, the first noise they make.
What if they sneeze?
All right, maybe not the first noise. So if Dean Holger doesn't end up being able to come, then
Just do the first grad student.
we'll just move right to the first student.
And
Yep.
it's like he's ready to go.
Yeah, okay. Okay.
Well, even if he came a little late, would you want to still?
Not if a student has started.
Okay.
But if he is here at the beginning of the second session, maybe we can do that.
Okay, that works.
I know he can't be here at the end, so, but I'm not sure about the rest of his schedule.
Okay.
And sometimes
well, just let me know.
Yeah.
They're pretty busy.
Yeah. Sometimes afternoons, people are used to starting at 10 after the hour, because of classes starting at 10 after the hour. I don't know if that's what he might be thinking, although I said 2 o'clock.
Yeah.
We'll see.
Yeah.
I think.
Okay? Okay.
You can go.
All right. Well, good afternoon, everyone, and thank you for being here. This is the Graduate College's first 3-minute thesis competition, so we're very excited and looking forward to this afternoon's event. I just wanted to mention that at Iowa State this fall, we have 5,096 graduate students on campus, which is a record. Most of them are pursuing master's or doctoral degrees that require that they do research that yields new information for society and provides a basis for solving important problems that we face as a nation and the world. So we rely on graduate students here at the university to carry out much of the research that gets done. During their degree programs, graduate students focus on communication. Most of the time, they're focused on communicating in writing, through journal articles that they're expected to publish, and through presentations at national meetings that they give. But those presentations and the writing that they do is generally targeted to an audience of their peers, to other experts in their discipline. This event, the 3-minute thesis competition, is designed to give students an experience with a different form of communication, trying to condense something meaningful from their research that can be appreciated by an audience of intelligent, educated people, but not experts in the discipline. So I think this is going to be a good exercise for all of the participants, and I want to thank them all for being interested in participating and putting themselves kind of out there, making themselves a little bit vulnerable through this event. And it's completely voluntary. No one said they needed to do this. When we advertised for the event, we decided that we could accommodate about 30 students, and we had far more than 100 students express interest. So it was a difficult decision to select the participants, but I'm sure they won't disappoint us today. I thought I would just mention a few ground rules that most of you may already know, but in case you don't, there is a very strict 3-minute time limit on the presentations. The rules as defined by the University of Queensland in Australia, where the 3-minute thesis was originated, state that if a student exceeds the 3 minutes by even 1 second, they're disqualified. There will be a timer here that the students are able to see as they're presenting. They're allowed 1 static slide, so no animations, no sound in the slide, and only 1 image. That image must be displayed throughout the entire presentation. And we're asking that there not be any questions or any applause between speakers. We want to move as swiftly as possible through the talks, and we'll have 15 talks, actually 14, in the first session because one of our students unfortunately was ill today and had to decline participation. So we will not be having speaker number 13 on the program. And we're asking that there not be any applause between the speakers and no questions. I will not be taking any time to introduce the speakers or recite their titles or their names. All of that information is on the program that you should all have. So you can refer to the program for their names and titles. We're very grateful for the service of 5 distinguished judges today, and I want to introduce them and thank them for their service. Dean Borg from my left to my right, Dean Borg is from Iowa Public Television and also Iowa Public Radio. Jane Acker, who is with the Ames Library on the Board of Trustees as president. Sherry Bates, who's a member of the Iowa Board of Regents. Beth Wessel-Crochelle, who's a member of the Iowa House of Representatives from District 45, and Amy Mayer from Iowa Public Radio. So we're very grateful for their willingness to participate. and we hope they find it interesting. We're just about to begin, but I'd like to introduce the Dean of the Graduate College, who will make a couple of remarks. This is David Holger. David?
Well, in keeping with the event, I'll keep my remarks to less than 3 minutes. This is really a very fun and interesting event, I think, both for the participants, the judges, and the audience. Our Graduate and Professional Student Senate has organized a number of these in the past, and unfortunately the timing, and Bill may have mentioned this, means that we had to have this additional competition this year. To the contestants, I would say this is really kind of a unique opportunity. You've done really specialized research that has led or will lead to a dissertation or thesis, and this is your chance to tell somebody outside your discipline about the exciting results and discoveries you've made in a very short period of time, and the 3-minute buzzer is real. So don't worry about it, but remember, you've got 3 minutes to do this. To the judges, I'd say I've done this in previous competitions. I don't envy you the task before you, but we're really grateful to you for taking time to do this, and to the audience as well. So these are really interesting and great opportunities for students. I wish I'd had the opportunity as a student, because I can't tell you how many times since then I've needed to try to encapsulate something in 3 minutes in a way that a very diverse audience can understand. So I'll stop there, and I look forward to some very interesting presentations. Thanks for being here.
Thank you, Dr. Hobart. A couple of final announcements before we begin. One is that could everybody please make sure your cell phones are silenced? And two, of course, this event is being live streamed and will be available also from a recorded version online. So welcome to those of you who are watching it over the internet, and for those of you who are watching it afterwards. Well, I think we're ready to begin with our first speaker, Robert.
It's too tall. I can't quite reach it. I'm sure many of you have said this, whether at home, at work, or at the grocery store, trying to reach that can off that pesky top shelf. Well, this is the same statement that wind energy providers have been making in the southeast United States for the past 20 years. Currently, our wind tower is set at 80 meters tall, but that's just not tall enough to reach the wind speed needed for viable economic wind power. However, things are changing. As you can see on the map on the right of the United States, the areas in orange show areas of new wind development that are possible if we increase our tower height from 80 meters to 140 meters. Now that's quite an increase, and you might ask, well, how is that possible? That's a good question. I'm glad you asked. Our current 80-meter towers are made of circular steel shells. Now these towers work great for 80 meters and even up to 100 meters without a problem. But if we go taller, we start to run into some logistical issues. The base of the tower expands out to over 18 feet, making it very hard to transport over the road or under overpasses. The other option is to constrain the base and actually put more material into the tower. But if we do this, we end up using twice as much material as we would for a normal 80-meter tower. And as you can see, that's just not cost effective. So it's clear we need another solution. And that solution, we hope, is concrete. Currently in Europe, they're using circular concrete towers. The problem with circular concrete, however, is that casting on a curved surface is both more time expensive and more time consuming than casting on a flat surface. And that's where the hexcrete tower technology comes in. The hexcrete tower, as the name implies, is a hexagon-shaped concrete tower made out of columns and flat wall panels. The beauty of this tower system is that everything can be cast on a flat surface at a precast concrete facility. Now, precast concrete facility is basically a factory where you manufacture concrete pieces and then ship it to the work site. So all the pieces are manufactured separately, shipped to site, and then put together with steel tendons. Steel tendons you can think of as high-strength steel ropes that are both flexible and durable. Now, these tendons act a lot like a drawstring on a pair of sweatpants. They run through a predetermined location in the tower, they're then pulled tight to bring everything together and tied off. In this case, they're tied off with mechanical anchorages. Once everything is tied off, the sections of the tower are about 30 to 40 feet apiece. Now we stack these towers on top of each other, these sections, until we get 140 meters or 450 feet. Now the beauty of this design is that it's just not a conceptual idea, but it's also becoming a reality. And the last picture you can see up in the right-hand corner is a test unit that we built in one of our laboratories. This test unit was actual from a real tower design, was subject to real tower loads, and performed very well. This gives us confidence that the hexcrete tower design is not only a novel technology, but a great solution for implementing wind power across the United States, and specifically in the Southeast at 140 meters. Thank you.
Good afternoon, everyone. So my topic today, as well as my thesis topic, is 50 shades of microglia. If you're wondering what I mean by 50 shades of microglia, let's first discuss what microglia is. As human beings, we're exposed to toxic substances, bacteria every day, but we don't fall sick every day. The reason is we have an army of cells in our body which can combat all these toxic substances and bacteria, which are called the immune cells. Microglia is one such type of immune cells, but they're resident in our brain. So their major function is they help in protecting our brain cells, which includes nerve cells, and they're important, as you know, in different functions. Where I come into the picture is studying this particular cell type in a disease pathology. Now, the microglia are very much like us human beings. We are very different from each other. The reason is our genetic component is very different. As you can see on the top half of our picture, a normal microglia is happy, but it can go to an extreme happy state where it gives off good substances like growth factors to the neurons, which helps to grow the neurons and also keep the neurons happy, which are important for normal functions of our brain. But it can also go to a stressed stage, which is harmful for our brain. And that's what happens in most of the neurodegenerative disorders like Parkinson's disease and Alzheimer's disease. The reason it can go from a happy stage to a stress test is because the genes inside them are different. And my thesis is about studying those genetic mechanisms which can change one microglial shade to another microglial shade. In this case, I've shown only 5 shades, but there are multiple different stages of microglia. Now, again, as I said, microglia are just like human. It depends on the environment how we react. Like on a Monday morning, if someone asks us to do some work, we'll generally do it. But on a Friday, we're kind of stressed. And on a Saturday, we're super happy. The same with microglial cells. It depends what environment we come across to, and the microglia react accordingly. So my thesis is about connecting both of them together, studying the environment as well as the genes. So there is an environment and gene crosstalk which makes this microglial biology extremely, extremely important for pathological diseases like Alzheimer's disease and Parkinson's disease. And in case you were wondering whatever I'm saying is at all true or not, on the right-hand side, it's an actual human section where you can see the red dots are microglial cells, and you can see how varied they look even in that particular brain. So their microenvironment is different. That's why they look so different. And that's what my entire thesis is, studying the environment and gene interaction in the microglial cells and how they're affected and what are the different shades of microglial cells. Thank you very much.
What did you eat for lunch today? Where did it come from? Did it negatively or positively impact your health? The food you choose to eat has a lasting impact on your health. And one of the simplest ways to boost your health is to increase your consumption of fruits and vegetables. My research focuses on how tomatoes are grown to positively impact the land, a farmer's income, and your health. How a tomato is grown can affect both its nutritional and flavor qualities. I take the best tomato shoots and roots and combine them together to make a plant stronger, larger, and more productive. Like a surgeon, I join two different plants together through a process called grafting. First, I select a close relative to the wild tomato for its root system. Wild tomatoes are tougher than their tame relatives, and they're more resistant to diseases. Next, I select a tomato that I want to grow and harvest. A good example is the popular heirloom tomato, Cherokee Purple, which has a great flavor, but a poor immune system. As a plant surgeon, I combine the desired shoot by putting it on the roots. First, I sever the stems, placing the shoots on the roots. Next, I join the two pieces inside of a small clip that holds the plant together as it heals. The final product is a stronger, more resilient tomato plant. We have learned that grafted tomatoes are more resistant to diseases. As a result, grafted tomatoes produce more high-quality produce than non-grafted plants. This has a positive impact on farmers as they are able to grow more tomatoes with fewer inputs, thus increasing their profits without compromising the land. The benefits of tomato grafting are also passed on to you as a consumer when you are able to buy and enjoy a high-quality tomato that is both flavorful and nutritious. So tonight, as you sit down to eat your dinner, remember, you are what you eat, but what you eat is impacted by how it was grown. Thank you.
All right, good afternoon. My name is Ashik Satish, and my talk today is on syngas fermentation for the production of renewable fuels, or just biofuels. So that probably all sounds pretty complicated, so what I'm going to try and do in the next couple of minutes is break that down and then explain what's going on in the schematic here. So there's a couple of things that are going on here. One on this left, or on your left side, it just shows that when we use gasoline that's produced from crude oil, we're emitting a lot of CO2, or carbon dioxide, into the atmosphere. And we all know that carbon dioxide is considered a greenhouse gas. And so this emission of greenhouse gas into the atmosphere from crude oil is not a good thing. It has a negative impact, and that's being discussed in a lot of places in this country and around the world as well. So one thing that we can do actually is take this carbon dioxide from the atmosphere and convert it into fuels and other chemicals. And this is done by the use of plants. So plants grow using CO2, water, and sunlight, and that's just photosynthesis. So what we can do is take those plants, and a lot of those plants are crops that we're growing. And so soybean and corn are some examples of these. So in the process of growing these plants and in harvesting and producing food and feed for animals and people, we generate some waste material, the stems, the stalks, corn stover, things like that we can use to produce chemicals and fuels from. And so those are considered waste plant materials. And so what we do, and I was saying what I focus on, the group that I'm working in, is taking this material and converting it into things that can be used by society, chemicals and fuels. So one process that we can use to do this is called gasification. So that sounds complex, but all it is basically you take this plant material and you put it in a reactor and you heat it up to a point, and under specific conditions, it actually breaks down and decomposes all the way to a gas. So essentially you just get a mixture of gases that come out of this reactor. And this is where my research focuses on. So this mixture of gases that comes out is known as syngas. It's made of CO2, carbon monoxide, and hydrogen gas. And what's really cool and interesting is there's bacteria out in nature in the environment that actually absorb these gases, and they use it as food basically to grow, and they also can produce ethanol and butanol, which are considered biofuels. And so what my research really focuses on is this process where we grow this bacteria in the lab and feed it this syngas and try and optimize that procedure or that fermentation process so we can produce as much biofuel as we can from the syngas we're feeding it. And so what's interesting is when we can produce this biofuel, we can replace a lot of this gasoline and crude oil-based fuels that we're using. And what happens is the overall big picture goal is that we can close that loop. So we can kind of push out the crude oil or the use of crude oil and keep using the carbon dioxide that's in the atmosphere and loop that around. And that, in the long run, is more sustainable and environmentally friendly.
Good afternoon. My talk is titled Data Detective Catching the Fraudsters. Okay, so a fraudster is a person who commits fraud. Okay, and in my talk I'll be talking about credit card fraud. And so this problem stems from a financial institution that is located here in the Des Moines metro area. Okay, and so I had the pleasure of working with this Fortune 100 company over the summer, and that is the motivation for my research here. So this company, they've got an audit team, and so they look at credit card transactions, and this audit team goes in and they audit the transactions, and they will give this transaction a 0 if it's a clean transaction, or a 1 if it's a fraudulent transaction. Okay? And so what we see here in the slide is up above that right dashed line, that area up there, we see 0s and 1s. And that's because this audit team is only able to audit transactions that are risky, transactions that are high transactions greater than $3,000, $4,000, on transactions that happen on high account balances. Okay? Accounts that are having balances of $10,000, $15,000, these are risky transactions for the company. Okay? And so they only have manpower to audit the small subset of transactions. And so that's what you see there, the 0s and 1s. And so what I did over the summer is I ranked all of those transactions up in that space. I said, these are most likely to be fraud. And the ones at the bottom of the list, I said, these are least likely to be fraud. So now this audit team can go in, they can go down from the top of the list, they can stop about halfway and catch most of the fraud. So now the problem that I'm working on here for my research is this other space, this unknown space, okay, for the transactions. Each of those X's represents a transaction. And so what we see is we want to be able to predict down there which of these transactions are fraud and which of these transactions are clean or not fraudulent transactions. Okay, and so my research focuses around the fact that we only have information in the corner of our space. Okay, so how can we use those 0s and 1s, those transactions we've already checked on, to predict whether these X's are going to be 0s or 1s? And so my research is focused around the idea that maybe those 0s and 1s up in the magnifying glass are too far away from the X's. They're not going to be useful or informative in predicting whether a transaction down lower in our space is fraudulent or not. Okay, so what I'm going to do is take these 0s and 1s closer to that border, that red line there, and say these are more like the X's that are near the red line. So we'll rely more heavily on those to tell us whether these X's near that boundary space are fraudulent or not. Okay? And this is a problem that, thank you. Sorry. Excuse me, sorry.
We're just going to give the judges a minute to write some notes.
Okay. It's not my size. How many times do you use the restroom? And what's the last time do you use the restroom? That's a really difficult question to anybody, either to the elderly people or for the 70 years old people. And I have a solution. You could live in a smart home lab, right? I work in a smart home lab in our state. Let's consider in traditional smart home, we have a lot of sensors around the house, including infrared sensor or the door opener sensor. But also, we have a lot of cost for the deployment. Even we have a lot of on-body sensor in your wrist and necks. But this will make you feel really uncomfortable, and that feeling will change your way to behave your activity. My research is recognition of activity of daily living. We use ADL for short. Okay, I can tell you what's your activity of daily living. I use smartphone. The basic thing is smartphone has a lot of sensors embedded, and I use a smartphone. Everybody, like the children or the elder people, they use smartphone and push the raw data to the server. Based on the server, we have the machine learning algorithm, which I developed. And then for the doctors, nurse, healthcare centers, and your family members, they have a reviewer app. And on their app, they could check your ADL every day, including what's the sleep status, what's the time distribution in every area, how often do you use the restroom, when did you go to the grocery store, and where you are. And you could find my location there. And we use the audio processing. Why? Because you could imagine that someday in that environment, okay, based on the noise environment, I didn't consider that a noise. That has some information there. I can tell he's in the airport, and then I can tell whether that's a sunny day, or whether there's thunder, or whether they're a plane taking off. Okay, and also I use the Wi-Fi localization. That could feasible in everywhere, and even in the basement where GPS cannot work there. And you could see the trajectory in my home. That's just an apartment. It's not a smart home. I use a smartphone. I can convert your smartphone as a smart home. So everybody have a smartphone, not a very new brand smartphone. And I can convert your out-of-dated smartphone into smart home service. So that's my research. And also, I have a patent for this technology. Thank you.
Ladies and gentlemen, I'm here today to talk about my research in creating devices that can keep hearts beating for longer. Me and my team will accomplish this by using a simple pump system that I invented as an undergraduate. This simple pump system has no moving parts, and the whole device can be implanted into the patient. What does this mean for humanity? Well, it means that we can keep people's hearts beating almost forever. This all started for me as an undergraduate in biological engineering. My girlfriend, now wife at the time, had to have a heart operation. This heart operation was to get her heart rhythm back to normal. If the operation went well, no more procedures, no medication. But if it didn't, it was medication and potentially a transplant. This got me thinking. So I started to look into the current technology for transplants and also for heart assist. And of course, I started to come up with ideas. And I built my own prototypes. And so the operation went well, and she is now healthy. But the seed was planted. So I started to think, and I started to dream, what can I do? How can I make hearts beat for longer? I made my first artificial heart concept into my senior capstone, and I had a breakthrough. I realized that I could use the power of magnets and electromagnets to create a simple pump system that could keep a natural or an artificial heart beating in a whole new way. This system uses electromagnets, which are basic coils of wire around an iron core. This, in combination with a solid-state magnet, creates a pushing and pulling movement that can keep a heart either natural or artificial beating. This combination is simple. It has no moving parts. And what this allows us to do is address some of the biggest problems with current technology. Current devices either have wires exiting them or have turbines and pumps, which can create blood clots and can damage the blood cells. Our device has no moving parts, and it uses wireless charging, similar to that used in cell phone technology. Also, without any turbines and any moving parts, you have a device that is not going to have any problems. Far less problems than current technology. So it might sound out of this world, but I believe that we can create a technology, a world where heart failure is no longer a death sentence, but just another part of aging. Thank you very much.
Hi, I'm an international student here, and I study international students. Data shows nearly 1 million of us are studying in this country, and our state has more than 3,000 of us. We all come from different countries, speak different languages, but we do share a similar goal, that is to have a great education here, maybe a better life. I remember before I came here for the first time, I had this image that I will meet great, knowledgeable professors who also understand my language issues, that I will meet welcoming American friends who will not only accept but also embrace and respect my diversity. Almost a decade has passed by since I first got here. You may ask, well, how did that image go? I would like to share a story first. I did a study on international students' American experiences a few months ago, and a participant shared me a story. She said on an evening she was walking with her daughter on a sidewalk. All of a sudden, a passing by motorcycle guy stopped and yelled at them with dirty words. They got scared, of course. She later on explained to me, she said, it's okay. Maybe he's too young. Maybe he's just looking for fun. You know, we look different. We are foreigners in this country. I was heartbroken when I heard that she has to use placebo explanations to feel better. So obviously, my image did not go well, which is fine, because I believe that imperfections makes us think, get better. Across this country, international students recruitment is a heavy business. They often have slogans like, come to our campus, this will be your home away from home. And looking at this picture, this building must be homes for several different people. This is the place for which these people have the deepest affection. So my question is, can international students call this place a home away from home? Or are we just cash cows? Thank you.
As technology advances, electronic devices are becoming smaller and thinner. A great source of device miniaturization comes from extremely thin and flexible sheets made of carbon. These are the sheets found in graphite that's used to make pencils. In order to make the most of these carbon sheets for nanoelectronics, it's necessary to securely contact them with metals that conduct electricity well, such as copper used in electrical wires. Historically, researchers developed methods to incorporate metals in a large chunk of graphite. The incorporation is in bulk, as shown by the red circles that spread throughout. However, such bulk incorporation is not small or thin enough for nanoelectronics. So in my research, I asked the question, can a conducting metal such as copper be incorporated just underneath the top carbon layer in graphite? If so, the drastic size reduction will be desirable for nanoelectronics. In my experiment, I create extremely thin holes on graphite by blasting it with gas. After depositing copper on graphite, I use a technique that's able to emit single atoms in order to observe the surface. It turns out that copper is able to diffuse through the tiny holes that act as entry portals and form tiny crystals just underneath the top carbon sheet. The carbon sheet is able to stretch and conform to the shape of the crystals. To illustrate how small and thin the crystals are, their heights are no more than 1/8,000th of the thickness of a human hair. The blue sky and hexagonal nets in the background show the viewpoint of encapsulated metals, and the relative thickness is like a single layer of plastic wrap around the basketball. Such surface incorporation is novel, and it spans a wide variety of metals. Not only do the metals securely contact graphite, the top carbon sheet can protect metals from degrading in air. My research pushes the limit of electronic device miniaturization. It shows promise and insights in nanotech electronics by incorporating conducting metals at the surface of bulk graphite. Thank you.
By a show of hands, how many of you like food? Did you know that bees alone are responsible for providing 1/3 of the food we eat? Bees are clearly important to us. For instance, take a look at what the produce section of a grocery store would look like without bees. As I'm sure many of you have heard, bee populations are declining. Most of this concern is for one non-native bee species, the European honeybee, which we rely on heavily to pollinate many of our crops. Most people are surprised to learn that here in Iowa, we have over 250 species of native bees that can do exactly what the European honeybee can do, only faster and more efficiently. Right now, our native bees are just as threatened as the non-native ones. One of the top threats is habitat fragmentation. Our landscape is dominated by corn and soybeans, both of which provide poor habitat for our bees. There isn't much for them to eat within these fields, and their nests are disturbed constantly by tilling and planting. What can we do? How can we make this habitat more bee-friendly? My research looks at corn and soybean fields that have been fitted with narrow strips of flowering vegetation. These strips have the ability to provide both food and shelter for our bees. Food in the form of flowers meaning pollen and nectar, and shelter, meaning an undisturbed place to raise a bee family. With a slight adjustment to our agricultural strategy, we can increase biodiversity, we can offer appropriate, suitable, attractive habitat for our bees, and continue reaping the benefits of pollination. Thank you.
Hi everyone. So today I'm going to try and explain to you how I use machine learning to assist in turbulence modeling. So turbulence is encountered everywhere in nature. Like we have it over an airplane when it's moving, over cars, inside of an engine, in the atmosphere. So it's pretty much present everywhere. So it's important that we predict turbulent flows correctly in engineering. So turbulent flows intuitively are very random, chaotic. And here, the top image, you can see that randomness and chaotic nature of the flow there. So in nature, turbulence is governed by what we call the Navier-Stokes equation, the first equation over there. So technically, we could, if we solve those equations numerically, or if we look at turbulent flows in nature, you'll get something similar to that top image over there. But the problem with that is that it's not very, well, you can't really use that in engineering from an engineering point of view. Because what you really need, say if you want to predict drag over an airplane wing or over a car, you need something, say like a quantity that's not really fluctuating, you know. So we need something more similar to the averaged version of the flow above, which is this thing. So you need something like that and not like that. And another problem with simulating that is that it takes a lot of time. If, say, I were to simulate turbulent flow over an airplane, something like that, over top, it would take me years to do that, quite literally years. So you can't really do that. So another approach is that we average those above equations to get a new set of equations down there. And you get like another term, like the last term of that equation, you get an extra term. So turbulence modeling deals with determining what that extra term looks like. So current turbulence models, they don't really give you the correct version of that term. So what I do is, we know, we run a turbulence model, we get the incorrect version of the flow field. We know what it actually should look like. We find the error, and then we use this artificial brain, what we call neural net, to we make it learn what the term should actually be like. And then once we plug in that error into the existing turbulence model, we can pretty much simulate new flows correctly. Yeah, so that's it. Thank you.
When I was young, standing on a footstool, watching my mom cooking, I noticed that the water she added into the wok never mixed well with the oil. Now, as a food scientist, I noticed that this phenomena is a very serious problem in food industry because nobody wants to drink a cup of milk or soup with a thick fat layer on top. Therefore, we add an ingredient, which is called surfactant or emulsifier. Surfactants and emulsifiers are molecules which have two moieties. The first one is called water-loving moiety, as represented by the red ball. The second part is called oil-loving moiety, which is represented by the black line. These molecules provide links between oil and water making oil well dispersed in water as droplets, and thus the food looks homogeneous. My research is to create novel surfactant or emulsifiers using biological sources, such as amino acid, fatty acid, or sugars. Figure 3 demonstrated the chemical reaction to synthesize the novel surfactant, which is called sugar esters. Sugar esters has the oil-loving moiety, which is fatty acid, and water-loving moiety, which is sugar. I have two findings of these sugar esters. The first one is that it stabilized oil in the water as droplets for a certain period of time. Figure 4 demonstrated my synthesized emulsifiers performance versus commercial ones. As we can see, at the third day, the oil started to separate from water, which wasn't very desirable for my products, so it still needs improvement. Whereas commercial sugar esters kept the oil stable in water system for 3 days, which is good. The second finding of my sugar esters is that it can retard bacterial growth. We don't want spoilage bacteria or pathogenic bacterial growth in our food because this makes food look dirty and it makes us sick. As Figure 5 demonstrated, the bacteria treated with the emulsifier stopped growth at the 5th hour, and the non-treated group continues grow. In summary, my sugar esters retard bacteria and stabilize oil in water system and make good looks homogeneous. If I'll tell this to my mom, she's gonna add the emulsifiers to the soup and make it very looking good. Thank you.
Hi, my name is Becca, and I'm working to decrease the number of deaths caused by malaria each year. Last year, over 400,000 people died from malaria, and right now, over half of the world's population is at risk of getting malaria. This is a disease that is caused by a parasite, which requires two hosts for its survival, a human and a mosquito. My research focuses on the mosquito, and specifically its immune response to malaria parasites. Every time a mosquito bites you, it's a female, and it's because she requires the nutrients in our blood to properly produce eggs. When she takes a blood meal from us, she's exposed to the pathogens in our blood. If she bites someone infected with malaria, those parasites develop quickly. 18 to 24 hours after the parasites are ingested, they begin to migrate through the gut walls of the mosquito. This process is extremely invasive, and in response, the mosquito will mount a robust immune response. It's at this point when my question comes into play. I'm curious whether mosquito hormones play a role in mosquito immune response. If you look at the figure over here, the hormone in red is called 20-hydroxyicdisone. It shows peak levels of expression 18 to 24 hours after the mosquito has taken a blood meal, which correlates with that time when the parasite is migrating through the gut wall, which leads me to believe, and leads me to my hypothesis, that 20-hydroxyicdisone plays a role in mosquito immune response. 20-hydroxyicdisone is known to play roles in mosquitoes with development, reproduction, and mating, but it's not known whether it plays a role in immune response. I conducted in vitro experiments by applying this hormone to mosquito cell lines, and in vivo experiments by injecting it directly into the mosquito. And what I found in both cases was a significant increase in expression of genes related to immune response. I also injected this hormone into mosquitoes and infected them with malaria parasites, and saw a decreased number of parasites developing in mosquitoes with additional 20-hydroxyicdisone. So if I go back to my initial question of whether these hormones play a role in immune response, my data suggests that they may be playing a role, specifically that 20-hydroxyicdisone boosts mosquito immune response. So if you think about my initial goal to decrease the number of deaths caused by malaria, you may wonder how this is going to help me do that. There are insecticides that are being used right now that mimic the roles of 20-hydroxyicdisone, but they're only used on immature mosquitoes, and they've never been used on adults. So if we use this insecticide on adult mosquitoes, we may be able to decrease the number of parasites developed within mosquitoes, the number of parasites that they give us, and ultimately the number of and ultimately the number of malaria cases each year. Thank you.
Ethan Fox was born a healthy baby. At 1.5 months old, his mother noticed that he had stopped bowel movement completely. He started getting sicker and sicker, and finally was diagnosed with Hirschsprung's disease. He underwent a 13-hour surgery at just 10 weeks old. Even then, he had to take help of special medical equipments to collect his waste until he could undergo another surgery at 6 months old. Ethan is 3 years old now, but he still faces challenges such as diarrhea, constipation, and leakage. Such are the challenges that a child with Hirschsprung's disease faces every single day. The saddest part here is that there is no cure or even a standard treatment other than surgery available. But the good news is that people like us are actually working towards it. So what does actually go wrong in Hirschsprung's disease? Believe it or not, we have neurons in our digestive system. A lot of them. In fact, the number is more than the neurons in your spinal cord. And these neurons help in absorption of digested food, blood circulation, but the most important function they serve is movement of your intestine. So this movement helps move the food from your esophagus throughout the intestine and finally outside the body. The Hirschsprung's patients lack these neurons in their colon. So their intestine does not have a normal movement like your or mine does. And this is caused due to developmental defects. In our lab, we are trying to find these factors that are involved in the development of the enteric nervous system. And we use zebrafish as our model organism. The big advantage of zebrafish is that they lay eggs, a lot of them, very short amount of time. But one of the biggest advantage is that the eggs and the larvae are transparent. So we can actually visualize the movement of the gut without cutting the animal open. There is an image of a 7-day-old larvae of zebrafish, and those bright green dots that you see in the gut, they're actually the enteric neurons. So we collect these cells, process them, and at this point, we are using statistics and computational approaches to analyze the data and figure out these factors that help in migration of the neurons from our brain to our intestine during the development of the baby and formation of a complete functional digestive system. So these factors will help us move forward towards discovering treatments and potential cures. I know we are far behind, but these are pioneering steps to helping kids like Ethan lead a normal and happy life. Thank you.
Should I go? Makes me, should I go to the?
Oh, is it a break?
Yeah.
I don't know. I guess we're having a break. I guess.
So at this time, we'll take a 15-minute break.
I guess there's a break.
Yeah.
Here, I'll take this. And then.
Thank you.
All right, thank you. Sorry about that. I didn't know they were taking a break.
Tight enough? Yeah, I think so. I mean,
I didn't know if I need to go any tighter.
maybe a skosh, but
checking out that one.
I know,
but-
most are.
Yeah.
I think most
Yep, yep.
still looks like.
Good.
So, but, yeah, I'm just gonna keep recording, because if I unrecord, I'll probably forget to go back into recording.
Sure.
So I'm gonna keep on recording both.
I stopped recording, but then I'll start recording again.
That's totally fine.
I do have like 5 minutes before it started, so if you,
Yeah.
I don't think you're gonna use my stuff anyway, but.
No, and I don't know how you're doing on card space, but if you want to switch to B, that's fine.
Okay.
Too. I can't remember if we, I think we have enough to get on one, but if we don't, we can just put it on the other.
What was 64, like 300 and some minutes, something like that?
Just, we only have one hour left, and I think each card had 190. Okay. So we should be able to get on one.
Thanks for your help, Arthur.
Oh, that really helps.
You're making it.
Yeah.
I thought I was.
Nope,
There's
you
no
don't get to.
Sorry, Ann, I wasn't going to blow you off.
Oh, no, I'm sorry.
When I'm doing this, I can't.
Yeah,
I can't
no,
take
I'm sorry.
any other input. I just get a
I
little
thought,
overwhelmed.
there was
so.
someone not, well, it turns out she was sitting on the other side
Oh,
of the room, so I didn't want
Okay.
the wrong slide to be up at the time. when
Okay.
I looked at-
I figured that Bill's driving that guy.
Yeah,
break
yeah,
taking Bill.
yeah, no,
So
I'm
I'm
What
just
time are you
going,
coming
oh,
back?
that's all right. That's all right. No,
5
that's-
after.
Oh, I didn't know.
5, 10 after. Okay.
Yeah, he's got a remote that he just.
Oh, okay.
Oh,
He doesn't
okay,
fly.
Yeah,
okay.
yeah.
Because now I'm trying to make sure
No,
everyone's
you
here
were
for this.
No,
next
no,
meeting.
I can't multitask that many things. I'm not smart enough. So.
Are you going to full screen at all, or are you just letting it?
I'm doing some full screen.
Oh, okay.
Yeah, on some of the busier stuff, I've done full screen. I've been trying to just kind of bounce around a little bit, so it kind of flows. But yeah, there's some good projects.
I do like how it moves, though, doesn't it?
Yeah, 33 minutes is kind of a nice length. Yeah.
Not mentally kind of, I mean, they're well under, most of them are well under 3, so.
Yeah,
I didn't want to go to grad school.
No luck with the hum, huh?
It's
somewhere, I don't know where it is, though.
It's okay. This is better than mine was worse.
Okay.
So it's.
Do you think it's interference, or is it just some plug that's loose? Or?
I don't know. It might be a little RF somewhere or something. Could be lights. Could be. I mean, there's a whole bunch of stuff up here, but it's fine. I mean, it's.
It is what it is for now.
Yeah, exactly. Yeah, we just if we would have had 2-3 hours. Yeah. Well, and I can take some of this out. Final cut out that some of the static. And that. But
I'm also thinking maybe next time we can get maybe a different room or even some of our own lights to. It's still extremely dark on my camera. I know it's okay, but it's not.
It's okay, but yeah, it would have been nice if there would have been some floods. There's nothing up here but can lights.
Maybe find a lecture hall. I don't know.
Yeah, I love lecture halls. Like even Benton is always awesome.
Jardine is really nice too.
Jardine is good.
Jardine's huge. I don't know. I'm wondering if they're getting the numbers they want.
Awesome.
We're going all right?
These guys are amazing.
Good. Glad it seems that way.
Yeah, it's really interesting.
Good.
Yeah, I think most are pretty good. Yeah, we have one pack that got different.
I got some. Okay. You want to put that in your pocket? Perfect. Someone's trying to get past you. And you can put the extra wire in your pocket if you want. There you go.
Yeah, sucks.
Yeah, and you can sit down and wait. If you want, you can sit or stand.
Yeah, I
whichever.
can stand, yeah.
Okay.
6, okay. Those are fun. So yeah, no, my brother has one of those.
Well, we had the 5, but we mixed them in with Dave and Julie's. And then when they were like, oh, do you want us to mix them out and go back to or whatever? And I think they have taken them out now because they didn't fit in a box anymore. And I was like, I will just order new ones. Then I saw that the 6-pack had come out and they come together.
One or two of those, right?
I don't know if it was cheaper, but it came together in a box. I think for like $6 or $35. It's not bad at all.
It sort of usually smashes 10 on its own.
Right. 5 or 10.
Yeah.
Yeah. And they're,
Well, yeah, because I played it through twice, and like the second time I'm like, oh, I've heard this one, heard this one,
right.
heard this
You
one,
get
heard
me
this
quite
one.
rarely.
Well, and the second time we played, we're at my college friend's house, and we've only known each other for 10 years, right? So there's 2 guys who are pretty close, and they know each other really well.
Closing in on time to get up there. Enter anything. Yes, I think it's a nice one.
I never did that. It's much work. Or maybe depends on what you do. I mean, some people love to cook. That's not my hobby. I like taking
So, like yours is just, of course we love this. We chose to do this for our entire lives.
Remember, there's water up here if anybody would like water.
Would it be frowned upon if we grabbed some right before we went up?
Well, as long as you don't hold it up there.
Oh, because it counts as a prop?
Yep.
Good to know. You know, I'm going to have my prop dehydration.
Okay, gotcha.
Okay, and then I'll just grab it from you. Oh, okay. So you want to, we can come back here too.
It's nice how you can make that. It's nice how you can make that banner so quickly.
Oh.
Yeah.
Oh, yeah.
Nothing to it, huh?
Pretty easy just to quickly edit it, yeah. And I did use some of that for
Okay.
quite a while, and then I just switched to this probably 2 minutes ago. Just to
Okay.
break it up a little bit. I was like, check over here, make sure it's still streaming. It's nice to kind of change things around. This is about a minute behind versus what I was seeing. It's been going pretty good though.
Yeah.
Like I said, I don't envy the judges though. There's a lot to take in.
To make some.
Probably would fry my brain. I think I envy a judge.
Yeah, and then you have, as difficult as it would be to make up your mind for yourself, then you have to form a consensus. So, yeah. Ready? Good. Well, it's time to begin the second session of the 3-minute thesis competition. Before we get started, I just wanted to mention that following these last presentations, the judges will spend a few minutes in a conference room nearby deliberating, and then they will return to the room and will announce first, second, and third place winners. All of the winners will receive scholarships. And the first place contestant will be representing Iowa State at a regional competition in Indianapolis in April that is held by the Midwestern Association of Graduate Schools.
Honeybee is the most important managed pollinator in the world. Pollination value brought by honeybee is around $16 billion in US. Honey production is around $3 million. And honeybees also created tremendous benefits to ecosystem. But US has more than 30% of colony losses in recent years. There are many reasons for this decline. Forage deficiency induced by agriculture is one of the major stressors. In Iowa, over 70% of land is used for agricultural production that extremely challenge honeybee forage resources. Imagine you are a honeybee. How do you feel like Iowa? The answer is no, not that good. So it's very important to find ways to provide honeybees with enough forage, including nectar and pollen. My work focuses on pollen and try to testify the hypothesis that complex landscape in central Iowa will provide more abundant and diverse pollen to honeybees than simple landscape. In my research, simple landscape has average of 80% of crop, but complex landscape, 42% of crop. each site, I find 5 research sites in simple landscape, 5 research sites in complex landscape. Each site is a circle area with 1.6 kilometer radius. In each site, I set up a honeybee hive with a pollen trap to collect pollen from the beginning of July to the end of September. The pollen abundance is determined by measuring pollen mass and diversity by identifying the taxonomic compositions. Does the landscape complexity affect honeybee pollen forage? The answer is no. The results show that complex landscape didn't provide abundant and diverse pollen to honeybees than simple landscape. The pollen from both landscapes are dominated by clover and partridge pea, accounting for around 90% of all the pollen. So it looks like that honeybee prefer clover and partridge pea so much. Another possible reason is that complex landscape in central Iowa isn't really complex, and it doesn't support diverse pollen forage plants. Thank you.
How many of you have thought about the perfect thing to answer to a class discussion or a meeting conversation while you're in the shower 3 hours later, or laying in bed that night asleep, or in the car on the drive home? And how do you share that information with your classmates or your colleagues? What if you're browsing the internet 2 days later and you stumble across a resource and you know that 3 of your classmates would really benefit from this resource? How would you share it with them? How would you share it with them if you only have class with them 1 day a week? Virtual learning communities are online components that give access to students and instructors 24/7. Students can access class materials, class discussions, they can share with each other, talk with each other anytime that they are online and wish to do so. When you're studying at 10 o'clock at night, maybe another one of your classmates is also studying, and if you have a question and put it into the online chat, they can respond to you. On-campus learning communities have been shown to increase retention, increase students' sense of belonging, improve critical thinking skills, and have numerous other benefits for students. Virtual learning communities show these same outcomes, but actually in greater numbers. My research looks at traditionally at-risk students and how creating these online components for them to access their education 24/7 improves their education. Thank you.
So as you can probably tell from my slide, I'm a restoration ecologist. That's a lot like being a conservation biologist, just the difference being that my focus is on restoring the historic function of a habitat or an ecosystem rather than a specific plant or animal. In my case in particular, I'm really interested in restoring American Midwestern prairie. Now, if you're from Iowa or this region, which I bet a lot of you are, you're probably familiar with the state of prairie degradation in this region. Most estimates put historic prairie at between 98 and 99.9% degraded relative to what was accessible pre-settlement. So one of the big points for optimism, though, is deeply rooted in the evolutionary history of these habitats. The two main things that prairie depended upon pre-settlement were grazing by American bison and periodic wildfires. So if you have pasture land and you are grazing cattle in the American Midwest, you are actually performing an ecosystem service in a lot of ways. So with only slight adjustments, cattle pastures can actually become very valuable habitat for these prairie species that really have nowhere else to go. In terms of the fire, prescribed burns on pastures can help reduce the amount of woody plants that are encroaching on otherwise quality pasture land, while also encouraging the return of these valuable prairie species and their associated pollinators. So knowing that we have these management skills, that with only slight modifications can make pasture land not only economically valuable, but also ecologically, the question then becomes, what more could we be doing in order to further accentuate this benefit that we're seeing? My project aims at analyzing that in two ways. First off, we have a series of experimental treatments we're applying, and we're comparing the results to see which one is best. In this case, we're defining best in partnership with private landowners as the removal of invasive and non-native plant species, but also the arrival of not only quality prairie plant species and their associated pollinators, but also quality forage plants for cattle. As a second component, to make sure that the benefits we're seeing now are also maximized in the future, we're doing computer modeling called species distribution modeling, in which you can use data from where a species is now to predict where it will be in the future. And that means in the face of a warming climate, we can be sure that the results that we're seeing now are going to be results that we see in the future. So by addressing both these sides, we can make sure that not only are these systems continue to be a refuge for these imperiled prairie species, but we can also maximize the financial value for people whose livelihoods depend upon these areas. That concludes my talk. Thank you.
Noise. Nobody likes it, right? And if you're like the farmer shown here, it can even make you want to sell your farm if you can't get rid of it. But noise is more than just a nuisance. It is also detrimental to your health. For example, the U.S. Department of Veteran Affairs spends more than $1 billion per year on hearing loss. With such widespread impact, noise reduction is no longer a nice to have, but an essential technology for next generation aircraft and wind turbines. So how can we eliminate the noise? Well, why not look for ideas by looking at the barn owl, the animal with nearly silent flight. As shown here, the barn owl has three key anatomical features that play a role in reducing noise. These features are the combs at the front of the wing, the fringes at the back of each feather, and the soft downy coat. For my research, I'll be focusing on how the soft downy coat eliminates the noise. We are currently collaborating with the researchers at Virginia Tech, where they've done experiments that have modeled the soft downy coat in a way that can be practically implemented in the industry field. They've done this by attaching these small structures at the back of the wing that they call finlets. They found out in their experiments that by using these finlets, they were able to significantly reduce the noise coming from the back of the wing. Unfortunately, though, the experiments alone were unable to identify the mechanisms behind the noise reduction. This is because it is nearly impossible to measure data with the spatial and temporal accuracy required in order to fully understand these mechanisms. And this is where my thesis comes into play. To overcome the accuracy limitations of experiments, I'm using highly accurate fluid dynamic simulations that will allow us to fully understand the mechanisms behind the noise reduction. These simulations will essentially be a computer model of the experiments done by Virginia Tech that will numerically compute how the air interacts with the finlet as it crosses the wing and how that reduces noise. The ultimate goal of our research with Virginia Tech is to bridge the gap between the experimental and theoretical understanding to unravel the mystery behind how the owl features reduce noise. You see, once we understand why these alpha features reduce noise, we can then create designs.
My grandmother used to believe that the only way to get a golden, flaky pie crust is by using lard, also known as pork fat. Nowadays, pork fat isn't quite a kitchen staple, and as the demand for pork fat diminished, the modern-day hog became lean and muscly. Now, if you're a chef or a grocery shopper looking to make a pork chop without that unsightly layer of fat along the edge, this is great news. However, sausage makers really rely on animal fat to give their product the proper flavor, juiciness, and texture. My research focuses on analyzing an alternative to pork fat for use in processed meats products. We did this utilizing a relatively novel fat replacer, which involved taking vegetable oil and turning it solid. Solidifying the oil first allows it to produce a frankfurter with similar texture to pork fat. So how did we solidify the oil? We heated liquid vegetable oil with as little as 2% of rice wax. Upon cooling, the rice wax forms a crystal structure which allows the liquid oil to latch on and become solid. It's similar to making Jell-O at home in your kitchens, but instead of using water and strawberry-flavored powder, you're now using oil and rice wax. Now, for those of you who want to know how to make a hot dog, I understand some of us prefer to keep it a mystery, but it basically starts out by continuously and rapidly chopping your lean meat, water, fat, and spices until the proteins from your meat perfectly encircle the globules of fat. Depending on the size of those fat globules, that determines the texture of your hot dog, so how firm or how chewy your hot dog may be. The frankfurters produced with the solid oil had larger fat globules, similar to those made with pork fat, indicating the solid oil was able to withstand the abusive processing that frankfurters must endure. Additionally, the frankfurters remained fresh for up to 98 days, which is a typical shelf life for a hot dog. There was also very little visual differences between the frankfurters produced with the solid oil and those produced with pork fat, with the exception that the pork fat had a slightly pinker center. There are many benefits to this research. We were able to replace almost 100% of the animal fat with vegetable oil. And as many of us know, vegetable oil is high in unsaturated fatty acids, which have the potential to reduce risk of cardiovascular disease, reduce risk of obesity, and increase immune function. This solid fat source is also customizable, so we can create it using omega-3 fatty acids, omega-6s, vitamins, and nutrients. So maybe in the future, eating a sausage will be a little more guilt-free. Thank you.
We all know that cancer is a terrible disease, but did you know that cancer is the top 2 common cause of death in US, and nearly 1 out of every 4 deaths result from cancer? This is mainly because a process shown here. You see there's a lung with a tumor mass. During the tumor mass growth, a few tumor cells can invade into the bloodstream, migrate along with our circulation system, and find a new site such as the stomach to reproduce another tumor mass. The tumor mass can be removed or killed by our current cancer treatment, but the treatments cannot do anything with the tumor cells circulating in the bloodstream, also known as circulating tumor cells, or CTCs. This is why after a few years or even a few months, cancer can relapse. In fact, 90% of cancer deaths is due to this migration process. So to stop migration, we need to figure out what changes they have made in the cells after they leave the tumor mass to make them resistant to our immune system as well as chemotherapies. My research aims to answer these questions by analyzing their genetic composition and protein residue and compare that to the cells found in the tumor mass to target the differences. To achieve this, we have to isolate them from the blood. However, CTCs in blood are like a needle in a haystack. They are so rare, only less than 10 CTCs in billions of normal blood cells. But just like using a strong magnet, we can attract the needle. Our lab developed a technique that using a variable electrical field as a magnet in which only CTCs can be attracted. We can then put a lot of chambers in the trapping position so that they can still stay inside even after we remove the electrical field. So the final device is like a muffin pan. CTCs are like muffins sitting inside each cup. We can then add reagents and run a few different steps at different temperatures so that we can get the information we need. If we can find the critical differences, we can then develop methods to stop CTCs from migrating. In a word, cancer patients will not have to worry about cancer relapse if we can eliminate the circulating tumor cells. It is simply a means to an end. Thank you.
All right, meet Jack and Nolan. Jack and Nolan are twin brothers who suffer from Duchenne muscular dystrophy. At 3 years of age, you can see at the beginning that they are prior to being diagnosed with Duchenne's muscular dystrophy. But at 3 years of age, they started to experience muscle weakness, causing them to stumble and fall more frequently than their playmates. As they continued to grow and live and play, they further damaged their muscles, and they started to begin to accumulate some unique features such as a poor posture as well as enlarged calf muscles seen in the second image. In addition to these large calf muscles, they also developed a very distinct walking stride. It resembles something like a waddle. As they continued to grow, by 10 years of age, they were falling further and further behind their classmates, and even while playing, they would experience shortness of breath due to degradation to the muscles involved with breathing. Finally, by their 12th birthday, they were becoming they failed to be able to walk on their own and eventually were wheelchair bound. Jack and Nolan are now 16 years old. Jack and Nolan will continue to have muscle damage and will result in them passing away from either respiratory or cardiac failure in their mid to late 20s. As you can see, these boys are in need of a cure. While my research is not intended to cure Duchenne muscular dystrophy, my job and my goal is to help these boys maintain a little bit more muscle function and a little bit more strength so they can live a longer life with more independence. My research is focused on a supplement called quercetin. Quercetin has previously been shown to decrease muscle damage and improve muscle function in a short-term mouse study. Quercetin functions by activating the SIRT1 pathway and results in decreased muscle damage through PGC1 alpha. In a long-term study, we were able to show that quercetin was able to improve muscle function and decrease damage. But as the study progressed, we found that there was less efficiency in that ability to increase respiratory function. We were perplexed by these results and soon began looking for answers to why quercetin would work for some time and then abruptly stop. Perhaps we can look at quercetin and the effects of quercetin like a car. So quercetin is the driver of the car, and he pushes on the accelerator. As the car moves forward and functions properly, it'll soon run out of fuel and coast to a stop. When it coasts to its stop, it won't be able to continue moving forward until more fuel is obtained. In this case, the fuel is NAD, also known as nicotine adenine dinucleotide, which is required for the function of SIRT1 to decrease muscle damage. So, the goal of my research is to determine the extent to which adding more fuel to the gas tank, that being NAD, we'll be able to decrease muscle damage and improve muscle function and allow these boys to live a longer, more independent life. Thank you.
Have you ever imagined how are we going to live without electricity? This world is going to be very different, right? Well, the electricity we're using right now is heavily dependent on the fossil fuels, such as coal, natural gas, and oil. However, it has been proven that in the near future, all of these fossil fuels are going to be used up. Therefore, we have to figure out other methods and other resources that we can get the energy for us to survive on this planet. Well, sunlight is a very good resource. Actually, the total sunlight that hits the Earth every year is more than 10 times of the energy over the global electricity production. So if we're able to develop a method that can utilize the sunlight effectively, we may be able to solve this energy problem. But how? One solution is to use solar cell. Basically, solar cell converts the light from light to electricity. That's what we want. As you may notice that we have solar cell commercially available, but they are not widely used. Why? Because the efficiency is low and the price is high. What I do in my research is to change this situation. So the main material for solar cell right now is crystalline silicon. What I do is to modify the property of the crystalline silicon, mainly by reducing the size to nano range. And in this nano size range, it's called nanocrystals. And nanocrystals for other material has been proven to have very different properties than the bulk material. So it is very likely that the silicon nanocrystals will have much better properties, much better performance than the crystalline silicon that has been used for solar cell. And if we can do that, we can get the silicon nanocrystal that have better performance. We'll be able to use it and develop a slightly different solar cell system to use these nanocrystals and to improve the efficiency and decrease the cost significantly. So my goal about my research is I will try to develop the silicon nanocrystals as solar cell, and we will be able to use the solar cell in our daily life in a few decades, so we don't have to worry about this energy problem anymore. Thank you.
Events like hurricanes such as Hurricane Katrina, tornadoes, violence, even the mass shootings that we see even in elementary schools in our country, or abuse and neglect are all examples of traumatic experiences that many children in our country and children around the world experience on a daily basis. And experiencing a traumatic event leads to very poor outcomes for children. It can lead to acting out, poor school performance, later substance abuse, and mental health issues such as post-traumatic stress disorder or PTSD. Luckily, we know that there are effective treatments for childhood PTSD, and one of those treatments is called cognitive behavioral therapy, or CBT for short. But what we don't know is exactly how or why or for whom CBT is working best, and we need more information about that. For children, we want to know what is the role of parents. There's some research that's suggesting that children and parents have a reciprocal relationship where they're interacting with each other to affect how treatment is working. But so far, there's only been a very few studies that show that. And so in my thesis, I looked at 47 children who had been through a traumatic experience and experienced PTSD as a result. And those children, and only the children, came to 12 weeks of a CBT intervention. And we did ask the 47 moms who brought the children to treatment to report on their child's PTSD symptoms and their own maternal depression symptoms. And the most exciting finding was that even though the moms received no treatment at all, their depression significantly decreased over the course of the treatment. But what's more is that they were part of the reason that their kids did better over time. And so what we know is that it wasn't just that child PTSD symptoms decreased over time or because of the treatment. Part of the reason they decreased was because the mom's maternal depression decreased as well. And I also found a reciprocal relationship. So part of the reason that mom's maternal depression decreased over time was because of the child's PTSD symptom decrease. So you can see in my thesis that moms and children really are affecting each other's mental health. And that's important to know, because if we can only get one of them into treatment, if we're treating the child, then we know we can affect the mental health of the dyad and of the family system. This is just one step in a journey of learning how and why and for whom these treatments work. And we really need more research in this area, because children will continue to experience traumatic events and they deserve effective treatments. Thank you.
Imagine that a disaster happens around you. The first thing you do to call or text someone asking for help. However, if the ground infrastructure has been damaged, then you will not be able to call or text. In my thesis, I proposed a smart solution based on drone communication that use a drone carried with a small base station to maintain the communication between the desired user and the main station. There are many applications for such systems. For example, it can also use for a temporary high traffic demands, like in Olympic Games, football concerns, where the ground-based station is not be able to serve a lot number of users. It also can be used in military application, where installing a ground-based station in forests, mountains, and sea will not be visible solution. More specifically, if you look to right-hand side of the slide, I proposed a smart solution combined with a smart distribution of the ground-based station supported by drone communications. So I formulate an optimization problem, and then I solve this optimization problem optimally to find the location of the drones. As you see in the bottom of the right-hand side, so here it's like a map for one drone. So the drone can go from one position to another position before back to the charging station, charge, and then go again. Also, we are currently working on apps can used in the smartphone or smartwatch in case that the user cannot go and use his smartphone asking for help. So these apps can automatically contact with the drone and said, okay, I'm here, I need help. In general, in my thesis, I study various techniques of smart and energy efficient for wireless communication towards smart and efficient cities. Thank you.
I'm an agronomist, and as an agronomist, I use science and technology to sustainably produce feed, fuel, fiber, and food for a growing global population. But before science and technology was around, there was a group of indigenous people down in the Amazon that deliberately left the remains of their cooking fires on the soil. And over time, this created soil that was very fertile and produced more crops than surrounding soils that were infertile. Today, we have expanded this idea using more advanced technologies in a process known as pyrolysis, which is simply the heating of any organic matter under no oxygen conditions. And we produce a very stable, carbon-rich product known as biochar, which you can see in the center of this slide. In addition to this, we face many challenges in the world today, including climate change and air quality issues, soil degradation, water pollution because of nutrient runoff, such as nitrogen and phosphorus, as well as limited crop yields and food insecurity around the world. Biochar has the potential to have a positive impact in all these aspects. So in my lab, we are looking at the mechanisms to improve crop yields. And specifically, I am interested in how biochar's relationship with water, soil moisture. How can biochar improve plant available water and water use efficiency in agriculture? It is very well known that biochar improves the water holding capacity of soils, but we have a very limited understanding of how this is actually available to plants. And as you can see, there's a lot of variability in the biochar. It's different shapes, sizes, colors. Therefore, it has different reactions when it's put in the soil environment. So I'm very interested in seeing how we can, in the long term, improve water use efficiency in agriculture and have greater crop yields and food production for everyone. Thank you.
One of the best moments in life is when you have a baby. You always want to keep your adorable one happy and healthy. But life not that easy, and babies get sick. Imagine if he got a flu-like symptoms, you will say 1 or 2 days and he will be okay. But unfortunately, he got worse. You take him to the clinic, and it's not the common cold. It's RSV, respiratory syncytial virus, which is one of the major causes of respiratory infection in humans. Globally, each year, about 3 million infants get hospitalized because of RSV. And guess what? 100,000 children die each year because of RSV. A solution is needed, since there is no vaccine or treatment available right now. The first challenge in studying any disease is to find a suitable animal model for it. Thankfully, in our lab, over the last decade, a neonatal lamb model has been developed and used. Not because lambs are cute as human babies, which is true, but because the similarity in pulmonary anatomy and size. In my study, I'm using a neonatal lamb model in collaboration with some pharmaceutical companies to test the efficacy of their innovative antiviral compounds, to make sure it's effective and safe before it goes into human clinical trials. What I did is to infect these lambs with RSV, and when the signs of infection appears, I treated them with the antiviral candidates. After the course of treatment, I explored whether this treatment were helpful or not. Thankfully, 2 of the compounds we tested were successful and now approved for human clinical trials. Hopefully, within a few years, we will find some of these antivirals available in the market to fight against this devastating disease. But not only that. In the next part of my study, I'm looking forward to study the virus itself and also the host. I'm investigating the reasons behind the susceptibility of some infants to more severe respiratory tract infection, such as the defective immune response and lack of airway secretion. I'm very excited about my work because as a researcher, I can see the desperate need for a solution. And also as a father, I can see the joy of future healthy families. Thank you very much.
Hello, my name is Alex, and I'd like to cure traumatic brain injuries, also known as TBIs. In the United States alone, over 50,000 people die from traumatic brain injuries in a single year, and an additional 300,000 suffer from long-term consequences. A TBI is defined as an impairment to the brain's functionality caused by an external force to the skull, like an explosion or collision. Many of you have probably watched someone battle with this frightening injury, but if not, let's look at the life of professional football player Mike Webster. It is estimated that Mike suffered from over 350,000 cranial collisions throughout his football career. Shortly after retiring, Mike was diagnosed with TBI after struggling to concentrate, and his body would shake uncontrollably. His desperate solution to calm the nerves was to zap himself with a taser gun. As you can imagine, his body could not take this very long, and unfortunately, Mike died at the age of 50. This is what traumatic brain injuries do. They take away the most basic functionalities of our everyday lives, and in the worst cases, they take away the gift of life itself, while doctors are left scrambling for answers. My research focuses on studying the active mechanisms inside the brain of a TBI victim, and there's a big one. It turns out that the formation of microbubbles is a leading cause of TBIs. Let's again use a football player as an example. When two athletes collide, there's an extreme pressure at the contact point of the skull, creating a low pressure at the opposite side of the skull. As the skull snaps back to original position, these microbubbles pop, sending shock waves to nearby neurons. Let me demonstrate the significance of these shock waves in another application. It is known that microbubbles form on boat propellers, and over time, the formation and collapse of these microbubbles leads to significant wear on the steel foundation of propellers. If microbubbles can wear away steel, then it is alarming to realize the damage they can have on vulnerable brain tissue. I am producing similar microbubbles in the lab and collapsing them on single neurons to analyze the consequences. These simulations will allow pharmacists to understand the structural defects in TBI situations and therefore design a better treatment to rescue neuron functionality. These simulations will also enable engineers to design helmets that will absorb energy in a precise manner so that microbubbles would not form altogether. Traumatic brain injuries have been devastating for vast amounts of people. Through my research, I plan to fight back and knock this problem in the head. Thank you.
Who here has ever driven down a highway and seen an oil jack bopping up and down like a giant seesaw? These oil jacks represent the conventional method of acquiring oil by using the oil's natural fluid pressure. However, after conventional methods have been used, there's almost half of the oil still remaining in the reservoir. Typically, these reservoirs are then flooded with water and then injected with steam, gas, or chemical solutions in order to increase oil mobility and reduce the resistive forces between the fluids. These methods are expensive and somewhat inefficient, and additional recovery from these wells are often abandoned in favor of new wells with lower production costs. Instead of drilling new oil wells, there's a low-cost way to recover the remaining oil from existing wells. This method is called vibration-enhanced oil recovery. Seismic waves from earthquakes have been shown to significantly increase production levels in nearby wells. These waves can be generated automatically with artificial devices placed inside existing wells that creates a vibration around the surrounding material and sends seismic waves up to several thousand meters away. Fluid and gas methods are limited to existing pathways, but seismic waves are able to spread out in all directions and are therefore able to reach a greater amount of trapped oil. My research project focuses on developing a computer simulation of the effects of vibratory stimulation on oil droplets. While it's important to pursue advancements in renewable energy, oil will continue to be our most essential resource for many years to come. The demand for oil goes far beyond fueling our cars. It provides us with electricity, plastics, and roads. Vibration-enhanced oil recovery is one cost-effective way that ensures that we will continue to have a reliable energy source, not just for us, but for our future generations as well. Thank you.
Today, let's take a moment to think about the development of the different cells of our body. So have you ever thought about how all these different cells all arise from one single embryonic cell? So that's a really important and interesting question for a developmental biologist such as myself. And I examined this problem by looking at the retina as a model system in animals such as the zebrafish, as shown right up there in the first panel, and whose eye development is quite similar to that of humans. So the retina is a complex tissue located at the back of our eyes, and if we could see it, we would see that there were many different types of cells present in the retina. So all of these different retinal cells with their very different morphologies and functions all arise from a common pool of progenitor cells. So how do these different cells all acquire their identity? So to answer that question, we need to look at the genetic profiles of those cells, right? Genes are components of the DNA, which are important for imparting specific characteristics onto those cells. So looking at the gene expression in these cells can tell us a lot about the nature of those cells. So so what I want to do is I want to figure out the genes being expressed in these cells, and often in the cases of diseases such as glaucoma, a fraction of those neurons or cells are lost, and leading to symptoms such as tunnel vision, which can severely compromise the quality of life of those patients and can eventually even lead to blindness. So my PhD project involves figuring out the cohort of genes being responsible for the development of the retinal neurons. Now, in order to do this, I can use computational analysis and find genes that may be potential candidates for this process. And in order to narrow down that list further and find genes that are necessary and sufficient for this process, I use this new technique known as CRISPR-mediated genome editing. So this technique has been in popular science a lot, and what I can do is I can go in and target the gene of my interest, cause a mutation, and cause that gene to lose its function. And so after many attempts and many zebrafish later, I found one gene which, when knocked out, can leads to the reduction of a fraction of retinal neurons. And so this tells me that this gene is very important for the development of retina, and I can use this information to go back and treat diseases such as glaucoma by replenishing the cells that were lost by the method of gene therapy. And thank you very much for listening.
Thank you to all the participants for the excellent presentations. We'll take a break of, I would guess, 15 to 25 minutes. I don't know exactly how long it will take the judges. They're laughing. But I would imagine the decisions can't be made in less than 15 minutes. But we need to be out of the room by 5 o'clock. So we will have a break, and when the judges return, we'll announce the outcome.
Stretching a little bit there, but can you stay for a turn? You want some help? Well, I have a tutorial meeting, but.
Empty these in here and then put it in the water fountain like this one's full. Okay, so it's gonna pick me up. I guess I can too. Yeah.
You shouldn't take them too long. Well, yeah. Those were amazing.
They were good. There was a lot of good ones.
Yeah.
I'm going by subject. Oh, yeah, yeah. Okay, yeah, we'll do a couple strips here. All right.
one was really interesting. That makes so much sense.
Short video.
It'll have to be the ag one. She's chemistry.
Yeah, yeah, they're so
But
pretty.
yeah,
But
there's
yeah,
a couple
there's a
ag
couple
ones.
ag ones, but yeah, like, there's the biochar.
Yeah, she was. She's really
I like hers too.
Presentation skills are excellent.
And did you have any Grey Goose in that picture there?
What's that?
Did you have any Grey Goose in that picture there?
Any what?
Grey Goose?
Oh. Unfortunately not. Yeah. 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 That's how we run.
That's right. That's to keep everything smooth, right?
That's right.
That's the way they used to do it.
Yeah.
Not anymore.
But,
They're all gone.
I
That's right.
shot
Part of Final Cut, it's hard to find decent quality curves.
Well, I've had decent luck in video blocks.
Oh, okay. I didn't even think about going there.
Yeah, in fact, there's a
I just did a little microbiology video on there today with the students. They invited a bunch of businesses.
Yeah, check
Brian wanted something on the front.
Yeah, check out video blocks. They have
I'll have
a
to.
lot of full background that they like. You can put them in your card, download them later. We'll just get them in your card so you can find them again. And I just downloaded a bunch of them. I just have them full.
Did you get all the free ones? So
Well, in our account gives quite a few that we pay. So.
well, if I wanted one that cost me, I
Well,
didn't know if I'd have to ask you guys.
Well, I mean,
I bet.
most of them. I mean, there's a pretty good selection of stuff since we are a member. That's.
Oh, okay.
There's a few premium things out there, but
I don't need
by and
that.
large, our subscription it's quite a few things.
probably longer than anybody else.
So I would check that out. Just search.
I didn't even think of that.
Search low. Like I say, I just download probably 10, 12 movies have that I just when I need one, I just go there and then just import it right out of the folder.
Yeah.
I don't
Oh,
have to,
that's
then I don't have to find it again or download it.
Yeah, when I
You know, so yeah, just find the ones you like, download to a folder, and then know where they are. Yeah, that should be good.
Oh. So Monday's a big preview of our Thanksgiving. Oh, I'm sure.
I mean, Finley liked it. I showed it to I sent it over to Lisa Scarborough.
Oh, good.
She liked it. She wanted to know if the food was tasty. And I said, well, first it wasn't that
Was there too long?
But, oh, well, I mean, most people I shared with, I shared with the premise of stuff.
Show me that. Well, I know the judges had a very difficult decision, but I appreciate their hard work and they did reach consensus. So I'm excited to announce the winners. By the way, Dean Borg had to leave, but he appreciates all of the presentations and thanks you all for participating. Our third place winner is Dylan Hurd. Dylan? Here's a certificate.
Thank you very much, sir.
And you'll be hearing from us regarding a scholarship.
Sounds good. Thank you so much.
Great. Oh, and by afterwards, if any of the contestants who want to have a photograph taken with the judges will, at least 4 of them will be here, and they love to have their pictures taken. Okay. Moving on to our second place winner, Taylor Wolfer. Congratulations.
Thank you.
And our first place winner, who will represent the university at the competition in Indianapolis in April, is Sweta Roy Carson. Wonderful job.
Thank you.
Congratulations.
Thank you.
Thank you all for attending. And I hope we will have an event like this next year at about this time, so please join us then. Thank you.